Welcome to Telegeography Explains the Internet, the show that explores the business behind all of the ways humans stay connected around the world. I'm your host, as always, Greg Bryan, and my guest today is Michael Wynston, Director of Network and Security Architecture at Fiserv. This is the third time I've had Michael on the show, and this time it was to help us all better understand how AI ML is developing as a network management tool. This is an area that he's particularly focused on and really excited to talk about. We start out with some history that goes back maybe further than you would think of how AI and automation networks got its start. And then Michael proceeds to take us through how they plan to train AI to sit up, crawl, stand, walk, and eventually run to help engineers manage their networks. We touched on many aspects of this process, and there is a lot to cover, so I won't delay us further. But no matter where you work in the telecom industry or even outside of it, I think this will be a clear explanation for you, it was for me, of where the industry currently stands with AI/ML for network management and where that might be headed. Enjoy. Welcome back to the show. Michael, I think this is your third or fourth episode. I should have gone back and checked, but yeah.
It is my third episode, Greg, and I'm very happy to be here. Thank you for having me back.
Yeah, absolutely. It's always a pleasure. It's great to. I'm always learning when I have you on. I've learned a lot in this podcast in general, but particularly with your episodes. But in case anybody is popping in and they haven't heard one of those episodes before, could you just give us a brief background on your company and what you do there?
Michael Wynston, Director, Network and Security Architecture for Fiserv. We're one of the world's largest financial services companies. The easiest way to explain that is anytime you have any transaction that does not include cash, so debit, credit, ACH, Clover, Zelle, a number of government platforms as well. If you're doing something and exchanging commerce or banking applications or paying a bill, some or the entire transaction passes through the Fiserv infrastructure. Mm-hmm. We're truly global in scope. We've got tens of thousands of endpoints located all around the world that do that merchant and bank processing. And so it creates a really interesting, complex, always evolving, almost I like to call it a living thing.
Mm-hmm. Mm-hmm. That is really cool. And you're the Director of Network and Security Architecture there. Give us a little picture of exactly what that entails.
Sure. So my role at Fiserv is to help identify new technology in the network and security space that can ensure our information is kept securely. And to me, I take that personally because I know my information, your information, and everyone I know and loves information is somewhere in my infrastructure. So I take it very personally to make sure that everything we do has a security first mindset. My role is also involved in selecting new networking platforms. So in the past, things like network function virtualization, networking as a service, SD-WAN, edge networking, and now what we're here going to talk about today, a little bit about AI and ML operations.
Yeah, absolutely. First, just let me say thank you, because obviously there's some other folks out there who aren't taking that as seriously, given all the notices I've gotten over the years that my information has been found on the dark web and whatnot which everyone at home, if you're not monitoring that, you should have some kind of service of doing that. Right?
But, absolutely. Yeah. If you are not using multi-factor authentication on your banking applications, on your shopping applications, especially with all the things you can now do through Amazon, if that account is not secured, you need to be concerned.
And I'll put in a plug for using an authenticator app, even slightly stronger than using a phone, text kind of message as well, even. So,
yeah, don't use SMS. SMS is the least strongest two-factor authentication Google Authenticator or the
Hmm.
Microsoft Authenticator or YubiKey, or there are so many ways you can do multi-factor authentication now. It's almost irresponsible if you're not doing
Yeah, there you go. Okay, good public service announcement way to start.
it.
Everybody at home,
Oh,
you just got an actual actionable kind of thing from the Telegeography
there you
Explains
go.
the Internet podcast, right? So, but today we're talking about something you mentioned AI ML that's been on everybody's mind. Nerds like us have been probably thinking about AI for a very long time, but it's really hit the sort of zeitgeist of late in the past couple of years of and maybe the sort of that critical mass of folks starting to see, what can this do with me? And we won't get into, whether large language models are truly AI or not, right? Leave that for some other nerdy conversations or whatever. But what I wanted to focus on with you, because you have been thinking about and even starting to implement some of this, is the real implications of AI ML for managing networks, right? So, and I should say this, Fiserv is probably a perfect example of another buzzword that is out there a lot nowadays, like fintech, right? So on places where you expect to see the cutting edge of this kind of stuff. So I think that's perfect. Yeah. So Michael, I brought you on to explain to us how we can actually expect to see AI play out in terms of network management. But I thought before we get there, let's start kind of with, I think, as you've alluded to me before, there's already kind of a history of AI and automation in network management. So let's maybe start with the roots of that and where you see the kind of nascent growth coming from.
So one of the things was actually a project I worked on going back 25 plus years. Wow, I'm old.
Yeah.
Was when I was working as a network architect at Merrill Lynch, a company that's no
Hmm.
longer, well, actually it's still around, but now part of Bank of America.
Right.
Anyway, was we were looking to implement a platform called Smarts. I'm not sure how many people out in the audience remember this going back that far. It was actually the first time I was exposed to it, and then I was exposed to it again when I was at a large pharmaceutical company. Smarts was a platform that was designed to correlate application to infrastructure so that you could understand the impact on your applications when you had infrastructure failures or outages.
Mm-hmm.
And the way that this would always work is you would build an application and infrastructure map. Back then, we were using SNMP to go and pull information from the network devices. And then we were using um, SNMP and other technologies. And the problem was back then for application platforms, most of those systems were proprietary to
Mm-hmm.
pull again information about that particular device. And then Smarts would try to map together the applications that it saw running on the hosts that it saw to the actual infrastructure itself. And then from there, the application and infrastructure folks would work together to build models based on how an application behaved. Because although it could find that there was maybe a web server running on port 80 on this host, and that host was connected to this switch, it didn't have the intelligence to then know, well, it has to go through this firewall, or there's this load balancer in front of it, or if I lose this piece of the application, here's the standby piece. So, because we didn't have that kind of technology around to dynamically build those relationship maps, all of that had to be done manually. And what would happen was you'd bring in a whole bunch of contractors to do that, to build it all manually, and it would work for a week, maybe. And the
Mm-hmm.
reason it only worked for a week is, as I mentioned earlier, infrastructure is organic. Infrastructure is constantly changing. Every time you plug in a new endpoint, every time you add a new router, you add a new switch, you add a new VPC, you add a new VNet. See, I'm adding cloud terms in there as well because that counts too. Every
Yes,
time
indeed.
you do something like that, your infrastructure changes. And because of this wonderful thing we use called dynamic routing, there is very much the butterfly effect, where you add a VNet somewhere in Azure and something over in a data center in Asia Pacific falls over, or the host suddenly can't get to where it could get to before. And those kinds of relationships are very, very complicated,
Right.
especially in large enterprise environments. So, Smarts, which is probably one of the early entries into this kind of application environment, was always hamstrung by the amount of effort it took to do that. Now, there have been more current tools like Big Panda and MoogSoft that have also tried to take this correlation on. But again, a lot of that correlation, a lot of those business rules take a lot of work to maintain and have to be done by humans.
Right.
And the challenge is then prioritizing that work for that human. Sometimes it falls to the bottom, sometimes it's at the top. Usually it's only at the top when you realize you haven't been taking care of it and something fell over and nobody knew. Or something happened and nobody understands why the impact was the way it was.
Mm-hmm.
So that's kind of the history of where we're hopeful that AI or artificial intelligence and machine learning can help us in an operational way. And that's what we're looking at right now.
Yeah, that makes a lot of sense, and I think it kind of tracks. Maybe it's a clunky metaphor, but with other AI as it's developed with us, right? So the one that I like to think of is driver assistance, right? So there's like types 1 through 4 in terms of automated driving. I've not yet had the chance to get into like a Waymo or something like that where it's like fully automated, but I have a newer car where it steers a little bit for me and I have adaptive cruise control. So you're kind of talking about that it's taking some of the burden off your plate. In this case, kind of like telemetry, if I'm reading you right. But then the burden is still on a human to understand what those data mean and what actions might need to be taken. Does that make sense?
It makes perfect sense. And one of the things to point out about what you mentioned, the burden, right? So there's a burden to risk correlation.
Mm.
We have reactions based on our experience. Artificial intelligence has a learning curve. And one of the things that a lot of the news stories and things I've read talk about the already AI is failing. Why is it failing? Because the learning curve. So if you put AI into
Mm.
your infrastructure today for operational support or engineering or whatever you're using it for, if you don't feed it quality data, if you don't feed it the data it needs to drive the decision that you want it to relieve you of that burden of,
Right.
then it's going to make mistakes.
Mm-hmm.
So I give you an example. My wife's new car has the ability to, if you're parked in a parking spot, you pull in, and then two people park too close to you, so you can no longer get into the car once you've gotten out of the car.
Right.
You push a button on the key fob, and it will pull itself forward or pull itself back.
Right.
Like, oh, that's really cool, right? Until you realize, okay, but now I need to be cognizant of if I have it pull itself back, is there a something behind the car that the car might not be aware of, out of the
Right.
angle of the camera, or maybe there's a software defect that the angle of the sun pointing at the camera causes it to think there's something there. Hence the reason I
Absolutely.
will not get into a fully self-driving automobile,
Yes,
because
exactly. Yeah.
I know how faulty software can be. So that absolutely terrifies me. But if we look at it from a network operations perspective, just starting with the basics, right? So again, it's not even crawl, walk, run. Can the
Mhm.
baby roll over and sit up?
Right.
If the
That's
baby
the
can't
stage
roll
we're
over
at.
and sit up
Yeah.
yet, don't ask it to reconfigure your data center fabric.
Right.
And
Yeah.
and having that expectation and understanding. So what's really interesting about this whole large language models and model training is the more quality data you can provide, the faster it can train. So for network infrastructure, where do you feed it the data? You can have the platform go out and connect to all of your network infrastructure and pull data in. Pull in routing tables, pull in CAM tables, pull in firewall state tables, pull in the load balancer, all of the information from your infrastructure. But then the first question I would ask is, okay, do you know that it's pulled it in from all of your infrastructure?
Mm-hmm.
And this leads to something I've been very passionate about over the last few years is hygiene.
Mm-hmm.
If you don't know your infrastructure, if you don't know how many devices you have and where they're located, then the information you're feeding into an AI platform, or really into any operations platform, is going to provide a faulty output or result.
Right.
So the first thing, before engaging in any AI or ML operations platform, is make sure you at least have a good handle, a really good handle on your infrastructure itself, right? All of your devices are properly managed. All of your devices are under the monitoring platform, or at the very least, in whatever source you're going to feed the information into your AI ML platform. Otherwise, it's making decisions without having all of the available data.
Right.
So, in looking at how you could use this, now go back to the correlations that engineers have to make on a daily basis. You have an incident, a switch goes down. When the switch goes down, how do you know which applications are impacted? Oh, they call us. Oh, well, that's embarrassing, isn't it?
Right. Yeah.
And that impact is industry wide because understanding what flows through that switch. Okay, well, we know something. We know the ESXi guests, the VM guests that are running on a hypervisor on that server that's connected to the switch. Excellent. We know something. So now I can, as an engineer, go into maybe a digital twin platform or something else that can discover both the physical and virtualized infrastructure. And now I know that that VM guest is running on that hypervisor that sits on that switch. So now when that switch fails, I can notify the compute and virtualization team. Great.
Mm-hmm.
What about the application people? Do they know? No. How do they know? Well, they call us to let us know that their application's down. Okay. Still embarrassing.
Right.
So what we're looking for in initially, because again, let's just get the baby to sit up before we just get to run, is something that can help us correlating all of the information that exists in our infrastructure. One of the things that we've been looking at for the last few years as an industry is observability. I hear all the people talking about data lakes and telemetry and application awareness and all of these things. And one of the things that AI and ML should enable us to do is actually leverage that data. Right? So everybody's building a data lake, but unless you can map all of the data together that goes in that data lake, mapping the switch, mapping the ESXi host, mapping the bare metal server, mapping the application, mapping the firewall rules, mapping on and on and on, then really you've just truckloaded all of your data into a single spot with no idea how to find
just
it. Right?
Sitting there, right? Yeah, it doesn't do you any good. Yeah.
So one of the analogies that someone made for me was, it's kind of like you've gone fishing in the data lake, and you don't know if you're going to pull out a prize trout or a radioactive boot, right?
Yeah.
And if you pull out the radioactive boot because you can't actually see or make the relationships into the data lake, you don't even know where it came from. Mm-hmm. So even with the data lake, you still have to send specialists to scuba dive into the data lake to find anything. So it doesn't accomplish some of the things that we were hoping that it would.
Mm-hmm. And is that a matter of, so I'm always thinking about things from the network side, and I'll say as we benchmark networks, we're talking about a slightly different layer of the network, like looking at what products you have. And I'm always really surprised to find that a lot of enterprises don't even have an inventory of what my connectivity is all around the world, right? So do you see, before you can get to that stage of employing the data I have in my data lake, there's this big effort of going through and having engineers understand this? Or is your goal to leverage the AI to understand it for you after you've fed it sufficient rules about that?
So I believe that every day infrastructure gets more complex.
Mm-hmm.
Every day there's a new cloud provider. Every day there's a new microservices platform. Every day there's a new networking platform. Every day there's a new kind of wireline or wireless type of connectivity, or networking as a service where you're running your overlay on top of somebody else's overlay who's maybe running it over another overlay that is
Absolutely.
running on some physical infrastructure, right?
It's turtles all
We
the way
don't
down.
know.
Yeah.
Exactly, right? So the
Yeah.
levels of abstraction have increased to the point where it's so hard for the engineers to figure out the impact of making even what should be the simplest change. Our infrastructure goes unchanged. And what happens then is we introduce fragility. Because if you're afraid to touch something because it's going to break, chances are it's going to break all on its own anyway at some point. That goes to whether you're maintaining the operating systems on your infrastructure. So we don't want to upgrade it, because to upgrade it, we got to reboot it. If we reboot it, we don't know what's going to happen to the things around it. So we can't upgrade it. Well, we just got this announcement about this CVE that says all of our infrastructure could be owned tomorrow by anyone coming from the internet. All right, well, then shut the internet off, because we can't upgrade the infrastructure because we don't know what happens if we reboot it. And this is the conundrum that we find ourselves in. So, doing this is to enable our architects, our engineers, to remove the complexity, the fragility, by simply understanding the impact of what is going on inside the infrastructure.
Mm-hmm.
And looking at some of the just most basic use case, you've got SFPs all around your data center, right? Tens of hundreds of thousands, depending upon how many switches you have. Those SFPs have a measured failure rate based on running at a certain temperature over a certain period of time. How do I know when they fail? Well, because the link fails, and then we do a whole bunch of troubleshooting. We unplug it, we plug it back in. The SFP didn't come up, so we put another SFP in, and oh, that works. Must be the SFP went bad. Basics, right? Imagine if I had a system that knew the SFP manufacture date, go out on the internet, pull the SFP's specs, and calculate based on the time up and temperature and light levels of that SFP when it's probably going to fail.
Right.
So you could proactively open a change to replace the SFP before it fails. Right? Very simple things, because those things happen every day, and it's purely reactive. So what did we just do? What we just did is we removed the potential unknown. We removed the possible impact to our customers, and we were proactively replacing something that was going to fail, and we had a system that calculated the likely fail by date.
Right.
And for a long time we've been pushing, we need to be more proactive in our operational mindset. The problem with being proactive is there's so much red that you ignore the yellow. And
right.
even if you clear out the red and you look at the yellow, if it's a whole sea of yellow, you don't even know where to start. You don't know which is more yellow going to red. Give you another example, another use case. When you build your infrastructure, most often you build things in pairs, right? An A and a B pair. As soon as you've built that A and B pair in your environment, there are specs for how much throughput you can get from A and B based on the number of features and functions you turn on, like an SD-WAN device or a firewall or anything that has additional features you can enable that reduce the CPU cycles. You put that A and B in, everything works great, no problems. Over time, you add more load onto the A and B pair. Over time, you turn on more features. Do you re-baseline to make sure that A can actually handle the load for B? Is it running hot, hot? If it's running hot, cold, how are you managing the drift between A and B? Right? These are all things that engineers need to be concerned with, but who has the time for that? No one has the time to do that. So again, imagine how much work it would be to do that on just one or two pairs of devices. It's a lot of work.
Yeah.
Imagine if I had a system that was always doing that.
Right.
Because nothing I'm explaining to you is something an engineer couldn't do. And not that they couldn't do it well. It's just time consuming and doesn't offer any real value to the organization. Doing what I just described with the A/B pair doesn't help move the organization forward. It helps you retain your existing customer base because things are not falling over. And then the customer calls you and says, hey, my stuff's broken. Oh, well, that's embarrassing. Sorry, we'll go look at it. Right? It enables us to be more proactive by telling us specifics about what we can do to improve or reduce the fragility of the infrastructure.
So move away from just putting out fires and instead moving to preventing them instead, basically. So, yeah, it does sound like though that in those two use cases that you brought up, the starting point, what's needed to even get that ball rolling, is that you need data, whether it's from the OEM or from other users spreading it. I don't know. Do you envision a sort of like a GitHub for AIs to learn, when the failure likelihood would be on this piece of equipment or something like this? How can we exchange that data between these systems?
So what's really interesting is most vendors now, most larger scale vendors now, have on their website API accessible specs and information about their platforms. So specifically, I know Cisco does this because it's leveraged. You can go on to the Cisco website with API calls with the proper authentication and authorization and be able to pull end of life, last day of support, end of software support, all that information via API. If I can pull the data sheets via API, if I can then take that information and then work that into my AI model, then I have an authoritative source for that information.
Absolutely. Yeah. That makes so if that's already in place, those APIs, then it's just a matter of designing the system to make those calls and be able to start processing the data. So it sounds like in what those use cases you're describing, we're kind of there. It's just a matter of implementation across all enterprise organizations.
It's a matter of finding or building the system that can do those relationships for you, and that's why organizations are either, as we always do, either looking for something you can buy or something you can build. There's a number of open source large language models that are focused around network infrastructure, so that if you have teams with the right skills, they could build that. There are also a few vendors that are now creating those types of foundational platforms that you can buy. Build versus buy is a whole nother interesting conversation that could take a whole nother podcast or series.
And I was going to say, I know quite a bit about your organizations. We've talked about this stuff over many years, and you have a lot more engineers on your team than I reckon the vast majority of enterprises with networks of your size do. So there's a different calculation depending on the skills at hand. And I should also say, I saw this chart just the other day from a sort of economist who follows the telecom sector of basically active employees in the telecom sector has actually been going down over the past several years. So I know, and I've heard that story from you and your colleagues at all kinds of different verticals in the enterprise infrastructure space, that it's really hard to find skilled engineers. It's not what people necessarily go to school, CS school for. Networking isn't the sexiest thing at the university level, and for whatever reasons, right? That's a whole other show itself. But what I hear you kind of like sort of getting is there's two issues there. Is that one, you have to have someone with those skills to build these systems in the first place, but then possibly having done that, you can overcome some of that skills gap using these tools, right?
But then you run into the challenge with maintenance. You run into the challenge
Mm-hmm.
with feature and function support. So the paths, right, is you either hire someone to do this, and you have to chain them to the desk because they can never take a vacation. They can't go anywhere, and you've got to make sure they document everything, which is in of itself a challenge sometimes. Or you can buy something, right, and then hope the vendor doesn't get acquired, and your product that you invested all this effort into, well, the vendor who acquired them decides that's not a strategic revenue source for us, so
Yep.
we're going to stop supporting it, right?
Mm-hmm.
So it's always a give and take, risk reward kind of decision. For us, we are trying to focus more on adding value to platforms that we can purchase that are extensible.
Mm-hmm.
So, in looking at platforms that are extensible, they provide a robust API set so that I can have the automation engineers work with the network engineers, or I have a number of automation engineers who are incredible network engineers. Go, okay, now that you've given me, instead of a pea shooter, I've got the ability to fire at a much more rapid pace.
Right.
I can do so much more.
Mm-hmm.
So, this is the whole AI is going to take our jobs. The cloud's going to take our job. It's not going to take your job.
Right.
It's going to enable you to do more if you're willing to learn how to leverage the tool.
Right.
If you still insist on driving the horse with a buggy whip and riding in a carriage, there's going to be limits to what you're able to do. And the call for those skills is over time going to diminish. This is the same thing.
Mm-hmm.
Yes, we will not have more people than we have now. We will have more of the right people than we have now.
And their productivity will just be that much higher, right? So it's very, very much just like the PC, right? It's like it's not that when we all got PCs, we didn't lose our jobs. We were expected to produce a lot more, right? So yeah,
productivity is increasing. And so now go back to that AI ML operations relationship engine, right? So the use cases I gave before, very basic. Mm-hmm. Now let's take it one step further. Okay, what information do I have in the infrastructure about the application correlation to infrastructure? Well, I have the firewall tables and load balancer tables that show me what specific application data using the tuple, or if you're doing layer 7 firewalls, even using URLs or other advanced protocol identifiers that can tell me this server talks to that server for middleware. Okay. And I can see that this server is hosting a URL that provides a front end for ordering something. So this is the order intake system. It talks to the middleware. And then if I go to the middleware that server is coming into, I can see that it's making calls to a database server out in the cloud. So now, using parts of the infrastructure that I have state information in, I can identify an application's actual communication path. Now, if I go to an actual application operations tool, I can look at the application's load. I can look at how the application behaves, how it responds to retries, how it responds to being told to back off, or all of those different pieces. And now, if I take the IP information that I got from the firewalls and load balancers and state tables and tie that into my routed infrastructure overlay or underlay, let's start at the overlay, I can find out what overlay that exists in. I can find the hosts that it resides on. I can find the container environment or the Kubernetes environment that that application is hosted in. I can get all of that information and track it end to end for one application. Just give me a couple of days.
Right.
Well, that's a problem. If you've got more than one app in your data center, and I'm confident that you do, then that amount of work I just described, that's man hours from now until, well, the end of time.
Yeah.
And the problem is what I just documented about that application, they added another server into the load balancer pool. Did you get that into your application model? No, hold on a second. Let me go. But we just got another one. Oh, I can't keep up. Okay. Everything I just described is something a human could do at a certain rate.
Right.
If I had a system that I could explain those correlations to, those relationships to, and I could feed it good quality data, then I could have this system continuously doing this. So now we need to upgrade router A. Oh, we need to upgrade router A? Not a problem, because the system that's checking the SFPs has told me the SFPs are all good, don't need to worry about reload, and the SFP gets a burst of light and tells it to shut down. Good. I also have the AB pair system running, so it told me if I turn off router A, I know exactly what the impact will be on router B. I know what routes will move. I know what firewall entries will have to change. I know all of that. So now that I know it, I can prepare for it. And now I know the applications that are going through router A. And I notice that this application that's going through router A, for some reason, its behavior might prevent it from going through router B, because something upstream is expecting some source NAT that exists on router B, but for some reason, due to drift, doesn't exist on router A. So now I can fix router A, so I can reboot router A after I've done my upgrade. And I can do that at a much faster rate because I have a system I trust that's giving me that correlation information.
Right.
So that is the crawl stage, right? So we got the baby to sit up and tell us about some SFPs, got the baby to roll over and tell us about the AB pairs. Now the baby can walk because the baby can actually walk around and say, oh, this application lives here and goes there. This application lives there and goes here. These two applications actually talk to each other through this NAT boundary using this DNS entry. And that's all information that your engineering teams can do as well.
Right.
But no one has the time or resources to do it constantly.
Right. Especially when there's other demands on them, right? So yeah.
Right.
Now,
the other demand. So what that also does is that reduces the amount of red, right? So going back to what we said before about getting past all of the sea of red, this is reducing the amount of red that shows up in your infrastructure.
But you've still, it sounds to me like, described a scenario where you have decided what data are relevant. You have decided the sources of the data. You've given the heuristics to the AI. So this is an engineer trained AI. Then what's the next step of removing the engineer sort of from that equation in the sense of the AI learning from other AI, right?
So let's rephrase your statement. We're not removing the engineer. We're enabling the engineer to do something that brings the organization forward.
Absolutely. Yes. Good correction. Absolutely. Yeah.
So what are we going to do next? Well, now that the AI can walk, let's go ahead and get it to walk a little faster. We're not running yet. By getting it to walk a little faster, how do we do that? Well, there's this term called intent-based networking, right? So intent-based networking means in some structured data form, JSON, you've gone ahead and written, or YAML, you've written how your application should be configured. You've written how the A and B pairs should operate. And a lot of folks are using this today in their automation, right? So you write an intent store in something like Notobot or Netbox or your intent store of choice. And then that intent is used through other automation platforms to generate configurations. So if I have the engineer write out what the intent is of how the data center fabric should operate so that all the VLANs that are on a pair of uplinks should always be the same, I can go and have the AI say to me, where don't they match?
Mm-hmm.
Where do they define the uplinks, right? I identify the AB pair of upstream switches. Where don't they match? Oh, they don't match on these switches. Okay. Propose to me what you would do to correct it. The AI shows, well, first question is it additive or subtractive? When you say make them match, do I make the one with less look like the one with more, or the one with more look like the one that's less? Well, oh geez, okay. So to figure that out, you've got to go look at the port groups on the ESXi host and make sure, see whether or not those VLANs are represented, and are there any VM guests? Okay, that's a step of logic. Now, if I hadn't given it that step, and I said it's additive, then the AI would have simply said, oh, VLAN 15 is not on this link. Let me just go add it. Now, why is VLAN 15 not on that link? Well, because something downstream was configured differently or incorrectly. And you can't have VLAN 15 on there because there's no VM guests there. You don't need it. Okay. So when it went and added VLAN 15, it might have created a spanning tree loop, causing the network to melt down. See, I told you that AI was no good. No,
Right.
it's learning, right? So
Mm-hmm.
how many network engineers who listen to this podcast made mistakes? If they're human, they've all made mistakes. How did you not make that mistake again? You learn from that mistake. So the more specificity in logic you can give the AI and how to derive those answers, the more likely it is to have the desired outcome. So now, because I told it go check the ESXi host to make sure that the VLAN exists there and there's some active VM guest, okay. Now it says, well, what it realized is that VLAN 15 should be here because there's actually a host on that ESXi server that's dead-ended if you lose this switch because it's actually cutting across to come back down. Ah, well, now I know to make it additive or additive and subtractive because I also noticed it's not just to add or subtract. I noticed you have VLAN 28 on this link, and VLAN 28 doesn't exist on any of the servers. It doesn't exist on any of the port groups. You don't need it. Take it off, right? So that's how we get it to start walking. We ask it to tell us what it would do to remediate the infrastructure based on the logic we've fed it, based on the data that it's observed, right? This is like teaching your children. Mm-hmm. You don't put your kids out in the world and say, well, they'll just figure it out. Right, because if you do, it's not going to end well for them. Maybe it will, maybe it won't. You're taking a chance. I'm not taking that chance. So, same thing here. In teaching it, now it's gone ahead and made that configuration adjustment. It worked out successfully. And now, based on that logic, instead of having it do one, you have it do five. Mm-hmm. But you don't have it do it until it's told you what it's going to do and you review it. And I bet you find something else you didn't think of the first time it did it. And each time you iterate, the success rate gets higher and higher until what's happening is as it's normalizing the infrastructure behind it, If that infrastructure deviates again from the normalization, it's much easier to fix because you know what it was before, you know what you did to remediate it, you know what was done to denormalize it, and you can go beat the engineer about the head who denormalized your infrastructure and didn't follow the intent model.
Mm-hmm. Interesting, right? So the iterative process isn't just the AI itself, right? So it doesn't know what it doesn't know, but also the engineers guiding it, right? That you need to know what you
Yep,
might not have thought of in terms of training it and whatnot, right?
exactly. And again, the more quality data you feed it, the more willing you are to take it through that iterative process, the more it can take those menial tasks off of your shoulders, the
Mm-hmm.
more fragility it can remove from the infrastructure until you reach the point where that engineer who knows how the AI ML ops platform works, where that engineer who also knows routing, switching, SD-WAN, VXLAN, all of the cloud technologies, can focus on what the business needs to drive the business forward. And instead of being perceived as a roadblock or speed bump, which network is perceived that way in a lot of organizations, you can be seen as an enabler.
Yeah.
Hey, we noticed that your application becomes very sensitive when the latency gets beyond 250 milliseconds. Because of the hairpinning between public cloud and the firewall that's on prem, you're going to occasionally exceed that. We've identified using our AI ML ops models that if we move your workload from this region in cloud to this region in cloud, which is closer to this edge data center, your application performance will actually improve and you can onboard more customers.
Right.
It's at that point where you have to help pick the customer off the floor because they've fallen down because you've never come to them
Yeah.
with something like that before, right?
Right.
Or if you do, it's a one off. Here we're talking about the ability to do that for the entire landscape of your environment,
Right.
which is why this has the potential to be so incredibly transformational.
Yeah, I'm really glad that you brought it up that way and with such a clear example because it's something that I talk about a lot on the show and in other sort of things I do, presentations and whatnot on this general topic of just the future of the network. That is exactly as you say. It's always been this cost center, this thing that IT asks for to be there as an afterthought, but instead we're looking toward this future where it can drive IT instead of follow IT necessarily, and be a part of the business strategy on how do I better reach my customers and serve my customers. So in that vein, you've brought us through the kind of sort of sitting up through walking. Can you give us just your rough idea of kind of where we are in that journey, both in terms of individual organizations perhaps doing some of this work, and then off the shelf tools, and what we expect to see over the next couple few years, near future?
So, first, don't believe half what you see and none of what you
That
hear.
is very important. Yeah.
Very
Yeah.
important, right? And that's actually a quote from a Lou Reed song from the New York album many, many years ago. I got a
Yeah.
head full of useless music lyrics. Anyway,
Yeah.
putting that aside, um, in looking at where we are today the maturity of these platforms is trying to build just correlation information, just
Mm-hmm.
enabling us to go all the way back to where I started with the data lake, being able to know where to go fish, to being able to use natural language queries to be able to extract information from the systems. But again, and I can't emphasize this point enough, it's quality data in, quality data out, which is the opposite of garbage in, garbage out, right?
Mm-hmm.
So it's important first to start with just basics of infrastructure hygiene, knowing where all your devices are, having your devices properly managed, or putting a system in that enables you to find all of the devices that you don't know about because you can't build the AI house if your foundation is full of cracks or
Right.
just missing large chunks. So where we are today is just building those relationship models. But if you look around, this is just a technology problem that's going to be driven as GPUs and CPU performance accelerates, as the ability to build more knowledgeable LLMs, more knowledgeable AI and ML that can derive this information much faster. And those are the kinds of things that we will see, I think, over the next 12, 24, and
Mm-hmm.
36 months.
Mm-hmm.
I think the next thing we'll see is these platforms will start being able to take information from um, your ops for your app ops platform, take data from your net ops platform, and they're just going to start selling you the ability to correlate all of this together, not replacing your platforms, but just the data correlation so that you can make more sense out of the data lake so that your operations teams can be more effectively proactive before we start seeing the automated repair infrastructure. I think we're at least
Right.
12, 24 months out from that.
Yeah, that makes sense. And just one more thing on that, because looking at the time, it's time to wrap it up. But I'm curious if you see it from the perspective of, do you expect this to come from a lot of existing vendors, or do you expect this to be a kind of a startup space for some of these new tools? Or obviously, maybe likely as a mixture of both. But what do you kind of see there?
I think it's going to come from the startups because
Mm-hmm.
the startups are taking technology from the web scale and cloud scale providers where
Mm-hmm.
their infrastructure is so big it makes my infrastructure look
Yeah.
tiny. And they have to have platforms that can do this because right now they have engineers
Right.
doing this kind of work with a lot of automation surrounds, but still not able to do those relationship mappings as quickly as they need it. So,
Right.
as in the past, when the telcos used to drive transformation, not as much anymore.
Yeah.
Now, the web scale and cloud scale providers are driving this so that they can build better platforms. And these startups that we're starting to see, that's where I think it's going to come from.
Mm-hmm.
I would highly recommend anyone who's listening to this go out, investigate AI, ML for network operations, learn a little bit of automation, listen to a couple of podcasts around LLMs and how they work, because a lot of this that I'm seeing will start to make more sense
Yeah.
once you understand the capabilities.
Yeah, absolutely. And I should say, as we wrap up here, Michael, that if anybody listening happens to be in Florida, you do run the Florida Network User Group, and I imagine you guys are going to be talking about this at some future meetups as well, right? So
I do. Actually, we're working to get another event on the calendar where I will be speaking specifically about this
that's all
particular
right.
topic.
Yeah,
So
I did not know that
very,
ahead of
very
time, folks, but
excited
there you go.
about
Yeah,
it.
yeah,
See, that was
excellent.
predictive analysis there,
Yeah,
Greg.
exactly. And other than checking out Florida Network User Group, which everybody should do, actually everybody that's in the network engineering space should look at the U.S. Network User Association. Lots of different state chapters there, so we may as well give that plug there. But any other ways that folks could keep up with you if they're curious about what you're up to?
Yeah, the best way to keep up with me is to just connect with me or follow me on LinkedIn because that's
Mhm.
where I spend most of my time doing my public writing or also talk about public speaking events. I'll be at the Gartner Symposium at the end of October doing a speak about leadership and transformation and leadership through change,
Mhm.
which is another really interesting topic and another plug for the USNUA or the NAF, the Network Automation Forum. I
Mhm.
will be out at AutoCon 2 as well, talking about our enterprise automation transformation journey. So if
Excellent.
you're
Yeah.
interested in learning more or listening to more, there are a number of ways to find me. Thank you.
Yeah, absolutely. Thank you so much for joining me again. This is probably one I'll go back and listen to a couple of times as time goes on, because it'll help me follow along with what we see happening out there. So much appreciated the excellent examples, and really appreciate when folks can speak in use cases. So I think you really achieved that here. So well done. Thanks.
Thank you, Greg. Appreciate it.
Yeah.
Always fun to do this.
Yeah, cheers. All right, thanks. Thanks for listening. Telegeography Explains the Internet comes from the experts here at Telegeography. It's edited and produced by Jane Miller, and it's hosted by me, Greg Bryan. And I also wrote that theme song you're listening to right now. To learn more about our data, jump over to telegeography.com, and we'll see you on the internet.